All right, in this video, we are going to be evaluating limits at discontinuities, and specifically infinite discontinuities and removable discontinuities, still looking at these rational functions where we have a numerator and a denominator. It's some function with a fraction in it. So at these infinite discontinuities, right, so as I start to approach the vertical asymptote, as I start to approach the x value of the infinite discontinuity, I know that I'm either going up to positive infinity or I could be going down to negative infinity. So the question is, well, how can I find if I'm going up to positive infinity or down to negative infinity? How do I know which one I'm going towards? Well, we're just going to plug in values. Say that we know it occurs at x equals 4. We can plug in values that are just to the left of x equals 4. So plug in like 3.99 and see if you get out a positive value, then it's going to go towards positive infinity. If you get out a negative value, it'll go towards negative infinity. All right, so on this side, say we're interested what's happening as we approach x equals 4 from the right side, we would plug in 4.01 or maybe 4.001, just a number that's directly next to x equals 4, so we can try to understand, is it going up towards positive infinity or down towards negative infinity at that infinite discontinuity. And then at removable discontinuities, these ones, well, I know that I'm just approaching some value. Okay, I'm approaching some value. It's not positive infinity or negative infinity. It's just, well, in this case, say that this resembles the line y equals, or f of x equals, x plus 2, except there's a hole at x equals 3, or removable discontinuity at x equals 3. Well, what would be the y value? What's my y value approaching? You're just going to take this and plug it in right here. That hole, the coordinate of that hole would be 3, 5 if it were filled in. All right, so just to get that removable discontinuity, you're just going to take what's left, right? What's left after you've crossed off the two factors that cancel with each other, and then just plug in the value there. And that will give you what the value would have been. All right, so let's try an example here because this is really going to be the easiest way for us to learn. So let's say our function is f of x equals x squared minus 2x minus 8 over x squared minus 3x minus 10. So let's factor numerator and denominator. Up top, this is x minus 4 times x plus 2. In the denominator, we get x minus 5 x plus 2. So first things first, we can understand, well, what are my discontinuities? X plus 2 appears in both the numerator and denominator, so we have a removable discontinuity at x equals negative 2. And I still have an x minus 5 left over in the denominator, so I have an infinite discontinuity at x equals 5. All right, at this point, let's try and evaluate some limits. All right, so with the removable discontinuities, going back to this drawing, I can see that my limit as I approach from the left and the right is going to be the exact same because I'm just approaching that hole. So we can just write, well, what's the limit of, and I'm going to just shrink this down, what's my limit of f of x as x approaches negative 2? All right, what's going to be that limit? For the infinite discontinuity, it might go to positive infinity on the left and negative infinity on the right, or the other way around. So I'm going to write out both of those. Let's see what happens as we approach 5 from the left, and what happens as we approach 5 from the right. So limit of f of x as x approaches 5 from the positive side, or the right side. So the limit of f of x as x approaches negative 2. All we're going to do here is plug in negative 2 to what's left. Okay, what's left after I've canceled out? So that's negative 2 minus 4 over negative 2 minus 5. That gives me a negative 6 over negative 7, which is 6/7. All right, so my limit of f of x as x approaches -2 is going to be 6/7. I apologize for the sloppy handwriting there. All right, I'm actually going to slide this. Let me move this over, this 5 from the positive side over, because we do have a little bit of work to do here. Okay, this is going to be a little bit tougher than the removable discontinuity with the infinite discontinuities here. So limit of f of x as x approaches 5 from the right. All right, let's start off by doing limit of f of x as x approaches 5 from the left. I am going to just plug in, let's say, 4.99. That's a point that is just to the left. That's an x value that is just to the left of x equals 5. If I were to plug in 4.99, well, 4.99 minus 4 gives me a positive value, plus 2 gives me a positive value, minus 5 gives me a negative value, and plus 2 gives me a positive value. That gives me a positive divided by a negative, which of course is a negative, which tells me that as the function approaches x equals 5 from the left, we will be going down to -infinity. So my limit of f of x as x approaches 5 from the left is -infinity. As I approach from the right, so now let's plug in like a 5.01. 5.01 minus 4 is a positive. 5.01 plus 2 is a positive. Positive, there we go. 5.01 minus 5 is a positive, and 5.01 plus 2 is also a positive. Positive divided by a positive is a positive, which means that as I approach 5 from the right, I will be going to positive infinity. So my final answer is positive infinity for the limit of f of x as x approaches 5 from the right. So let's just graph this now. X squared minus 2x minus 8 over x squared minus 3x minus 10. Let's clear this. X squared minus 2x minus 8 divided by x squared minus 3x minus 10. If I graph this, so I said as I approach 5 from the right, I'll be going up to positive infinity, which I can see that is clearly happening. As I approach it from the left, I'll be going down to -infinity. And then as I approach a -2, I will be approaching 6/7. So 6/7, that's about 0.856, I believe, or something along those lines. So you can see, yeah, I'm getting pretty close to 0.856, or 857, I guess it is. All right, and then boom, I hit -2, comma, undefined. So my y value, as my x approaches -2, my y value is going to 6/7. All right, so this is how we find and evaluate limits at infinite and removable discontinuities.